Here we're looking at parametric equations, and on screen you can see there are two of them. And so the variables of x and y are given as a function of another variable, in this case t. With parametric equations, you would have rearranged your equations. You may have squared both sides or added something. You may have used a trig identity, and then you would eliminate t and rearrange it again. With parametric differentiation, the first thing we're going to do is we're going to put in or sub in our values for x and y that we were given as 0 and 6 to find our value for t, which should be the same for both. So when x is equal to 0, t squared minus 4, so t is equal to minus 2 or 2. So one or the other, we'll see. Okay, x is 0, y is equal to 6, based on that point we were given. So 6 equals 3t, so it's very clear that t is equal to 2. So for both of these, t is equal to 2. So often the first thing you do, or second in this case, is you'll find the dx over dt or dy over dt, which is in a sense trying to use the chain rule to differentiate the equations. And then from there you can find it in terms of t to find actually t, and then at the end I suppose you could sub in t into your dy over dx to find the gradient. And that's kind of how this stuff works. And you'll come across tangents and normals, and the chain rule is used quite a lot. So we found our dy and dx is 3 over 2t, and we can now sub in our value for t. So 3 over 4. And that's our gradient. So from there we have more details. We have to look at a tangent of a point, of that point, which is parallel to the normal at point P, and find the coordinates at that point. So the gradient of the tangent is 3 over 4. Okay, looking for the gradient of the normal. So you may recall there's a formula for this. So you have dy over dx, which is your gradient of the tangent. So the normal is minus 1 over dy over dx. In this case, is minus 1 over 3 over 2t. So just recall that we had 3 over 2t was dy over dx in terms of t. So we have minus 2t over 3, which is we just calculated there, is equal to the gradient of the tangent, which is indeed 3 over 4, which we just did. So multiply across, as I said, and you'll get minus 8t is equal to 9. So t is equal to minus 9 over 8. So you'll notice there's quite a bit of rearranging going on in these questions. So as I said, it's minus 9 over 8. And now that we have that value, we can plug it back into our original parametric equations to find the coordinates for x and y. So for our first one we had x is equal to t squared minus 4. So it's minus 9 over 8, square that, minus 4. And you'll get an answer. Use the calculator for that, of course. And y is equal to 3t, so 3 times minus 9 over 8. So the final answer is minus 175 over 64 for x and minus 27 over 8 for the value of y. So there are exact values, and rewrite them there out just so your examiner can see them more clearly in that way. And that's this question on parametric differentiation. This question on parametric equations involves trig functions. You'll need to know that the derivative of sine is cosine, and the derivative of cosine is minus sine, And we'll also be using the chain rule for our x variable. So to derive 2 cosine 3 theta, which is dx over d theta, remember that cosine is minus sine. So where does the 6 come from? Well, it's the chain rule. So the inside part of 3 theta, is 3 times 2. So that we can bring it out the front, if you don't mind, at the end. So minus 6 sine 3 theta. Second part, dy over d theta. 5 sine theta is equal to 5 cosine theta, because the derivative of sine is cosine. An interesting part of this is to look that up on a graph, how it works. You know that there's a 90 degree or pi over 2 difference between them in terms of their periodic pattern. So have a look at that yourself to investigate it. dy over dx, and then you can simplify from there, if you can. You cannot simplify when you have like the 3 theta for sine there. It's not the same as what we have for cosine. So you could have had cosine over sine, which would be cotangent, but doesn't particularly work here. And the same thing if it was sine over cosine, which would be tan theta. We cannot simplify it in that way there, in case you come across that again. So now we're going to find the gradient of the tangent at a point. So pi over 4, we're using radians of course here. You know that pi over 4 is 45 degrees. We'll put it in as it's written. So we would put in our gradient now, gradient function, and replace the values of theta. And it should be a nice handy minus 5 over 6. So in a sense, the calculator does the work for you there, but you probably should know those values off by heart anyway, or look at them. Okay, we showed that, and now hence. So hence, of course, also means usually using, apart from a question previous. Hence, find the equation of the tangent. Okay, so your equation is y minus y1 equals m, and then brackets x minus x1. We're going to get to that in some way, so we need to find an x and a y value. So we're going to plug it back in, so our data function, and we're going to plug that back into our original parametric equations. So 2 cosine 3 times pi over 4. And the same for y. We'll do exactly the same thing, and you'll get your answers and then plug them back into an equation for the tangent. So y is equal to 5 sine times pi over 4. So x is minus root over 2, and y is equal to 5 root 2 divided by 2. So from there, it's not too far. You're just dealing with your equation of the line that you know from GCSE, I'm sure. And we want to write it in a certain convention, even though it doesn't state. I would tend to write it as y equals mx plus c, just to have it like that. But it often asks you to write it in a different way. So just be careful of that if they ask. Simplify the terms, and you'll get y equals minus 5 over 6x plus 5 root 2 all over 3. And that's your final answer for this. So these are 2 questions based on parametric differentiation.